Okay, this is section 5.3, and this is inverse functions. Okay, so first thing we're going to talk about is graphing the inverse of each function. Okay, so if you remember in the previous chapter, we talked about inverses. And the big thing with inverses is that they trade the place of x and y. So in each one of these ordered pairs, you have an x and you have a y. So here's an x, here's a y, here's an x, here's a y, here's an x, here's a y. So all it's doing is taking this x and making it the y, and taking this y and making it the x. So this point would turn into 7, negative 4, 7, negative 4. This point would turn into 3, negative 2. And this point would become 7, 0. So you can see if you were to do the graph of that, you would see something like this. And remember that this is going to be reflected across the line, y equals x, like this. So if you were to take this as a piece of paper and take this and fold it across here, this red one would land exactly on top of this blue one here. Okay? So this one's a little bit tricky, so we're going to do a couple of different points than the ones that are listed here. So 5, negative 2 would become negative 2, 5. 3, negative 4 would become negative 4, 3. And 4, negative 3 would become negative 3, 4. Now, this looks like a straight line, but we know that it can't be. So we're going to kind of look at some of these other points here. So we're going to take this point here. We're going to call that 6, 5, which would become 5, 6. And this point down here then would become, let's see, I believe that is 2, negative 10. So negative 10, 2. So now you can kind of see a little bit better. This graph is going to look something like this. Okay, and on this last one down here, on this last one down here, again, same thing. We're just taking these points and we're just trading their places. So 0, 3 would become 3, 0. 1, 4 would become 4, 1. And 4, 5 would become 5, 4. And so again, you'd have something that looks kind of like this. And again, if you were to put that line y equals x in there, you can see that that's going to be kind of like the fold if this were a piece of paper. All right, so today what we're going to talk about is we're going to talk about these functions called logarithmic functions, and these are just the inverses of exponential functions. Okay, so we want to be able to graph them, and we want to be able to write equations for them. So again, if you need to pause, if you need to rewind, rewatch, take notes, any of that kind of stuff. Okay, so the function that is showing right now is 2 to the power of x. Okay, and that's this red graph right here. And what we want to do is graph the inverse of that function. So if this is our x and this is our y for the exponential function, then for its inverse we would switch those. So our points would be 1/8 and negative 3. So 1/8 and negative 3. Okay, 1/4 and negative 2. 1/4 and negative 2. 1/2 and negative 1. 1/2 and negative 1. 1, 0. 2, 1. 2, 1. 4, 2. And 8, 3. So now our graph is going to look something like this. Now, you notice that this graph starts to get close to this axis, right? So now our asymptote has actually changed. Okay? It's no longer going side to side. It's now going up and down. Okay? So for f of x, that is the red graph. Okay, so I'm going to put this on here really quick. Okay, we've got our asymptote, okay? Find the following. Domain, which again, same thing, it's an exponential function, so it's negative infinity to positive infinity. Our range goes from the asymptote to positive infinity. Our asymptote is y equals 0, and our range is going to go from 0, because that's our asymptote, to positive infinity. Now, remember in one of the previous, we talked about how all exponential functions have these same similarities, right? So for exponential, right, we know that they all go through the point 0, 1, 1 base, and their asymptote is always at y equals 0, okay? For the inverse of the exponential, remember, inverse just switches x and y, right? So if this is our x and this is our y, for the inverse, it's going to be the opposite. It's going to go from 0, 1, it's going to go through 1, 0. Instead of going through 1 base, it's going to go through base 1. And instead of this being y equals 0, because remember, x and y switch, if this is y equals 0, then this is going to be x equals 0. This is a horizontal, this is a vertical, okay? Now also remember, in the last section we talked about domain and range. Remember, domain is all of your x values, range is all of your y values. So if x and y switch for the inverse, then that means that the y here becomes the x down here. So now instead of the range being from 0 to positive infinity, now the domain is going to be from 0 to positive infinity. And I should probably change colors for all of this because it's not the parent function, it is the inverse of that parent function. So these are always going to go through 1, 0, base 1, and it's going to be x equals 0. So this is vertical. Okay? Domain. Domain is going to be the range from the parent function. So it's going to be 0 to positive infinity, and the range is going to be the domain from the parent function. So negative infinity to positive infinity. And the asymptote, remember, we just replace y and x with each other. So if this is y equals 0, this is going to be x equals 0. Okay? So remember, the big thing with inverses is that x and y trade places. We replace x with y, we replace y with x. Okay? So we don't really know how to write the equation for the inverse yet, so that's what we're going to look at now. The inverse function of the exponential is known as the logarithmic function. And so if this is the exponential, this is the logarithmic. Okay? So a couple of things that I want to point out to you. This is your base. This is your base. This is written as a base like with your exponent. This is written as a base like a subscript. Okay? This, remember, just means this is the inverse of something. We took the inverse and this is what we got. Now, this could also be, this could be f of x is equal to log a of x, and this could be f inverse of x is equal to a of x. So it just depends on which one you start with, but they undo each other. So if you have an exponential function and you want to solve for the exponent, you would use logarithms. If you have a logarithmic function that you want to solve for, you would use exponents or exponential functions. Okay? So the inverse function, right, of the exponential function 3 to the power of x, we want to graph that, and then we want to write the equation of that. So this is the function f of x equals 3 to the power of x. We want to write the inverse. So remember, this one, the parent function, is going to go through 0, 1, 1, 3, because this is the base, and it's going to have an asymptote of y equals 0. So because we're writing the inverse of this, the inverse is going to go through the point 1, 0, trade these two, 3, 1, trade these two, and instead of y equals 0, it's going to be x equals 0. So remember, this is horizontal, this is vertical, okay? So our new asymptote for the inverse of the exponential function is going to be this. Our points are going to be 1, 0, so 1, 0, and 3, 1, 3, 1. And so this is going to go up like this, and this is going to come down like this and get really, really close to that asymptote. Okay, now, for the parent function, right, we know that the domain is going to be from negative infinity to positive infinity. It's going to be, we're going to do the asymptote first. The asymptote is going to be y equals 0, and then the range is going to be from 0 to positive infinity. The inverse, remember, is going to switch the x and y. So if this is the x and this is the y for the parent function, it's going to switch for the inverse. So the y is going to become the x, so it's going to go from 0 to positive infinity. The x is going to become the y, so negative infinity to positive infinity. And the asymptote, instead of being y equals 0, is going to be x equals 0. Okay, so if we were going to write the inverse of this function, right, you can see here, this is my base, this is my exponent, base, exponent, base, exponent. We're going to write this as log base 3 of x. Okay, we're actually going to skip over a couple of these pages. So let's look at this one now. Okay, the transformations of g of x. So we know that this is our parent function, and this is the graph of our parent function. So we can see that our asymptote is right here. Okay? Now, this is telling us that we have two transformations to do. It's telling us that, remember, with the x inside the parentheses is left and right, and we change the sign. So this is going right to, outside of the exponent or outside the parentheses, it's up and down motion, and we keep the same sign. So this is down 3. So we're going to take everything on this graph and we're going to shift it right to and down 3. Now this time you're not going to be able to see the vertical shift of this graph, but you'll be able to see the horizontal shift. So we're going to take this asymptote first and we're going to move it right 2 and down 3. So our new asymptote is going to be right here. And now we're just going to take all of these points and move them right 2 and down 3. So right 2, down 3, right 2, down 3, right 2, down 3. And so our graph is going to look like this. Okay, again, domain is all the x values. So before we can do domain on this one, we need to do the asymptote. So the asymptote shifted from x equals 0, it shifted 2 to the right, so it's at x equals 2. So the domain is from 2 to positive infinity, and the range is from negative infinity to positive infinity. Okay? Transformations of this. When there's a negative sign inside the parentheses, that just means that we are going to reflect across the y-axis. So we're taking all of these points. Our asymptote is still going to stay in the exact same place because our asymptote is on that line of reflection, the y-axis. So it's going to stay the exact same. It's just these are going to flip across the y-axis this way. So they're going to be the same distance away from that y-axis. It's just going to be on the other side. So it's going to look something like this. Again, your domain now, has also switched and your range has switched. So now your asymptote is going to be at x equals 0, just like it was before. And so your domain this time, because it's coming from the negative side, is going to go from negative infinity to 0, and your range is still going to be from negative infinity to positive infinity. All right, so we're going to graph this one, and then we're going to talk about writing the equation here really quick. So to graph this, remember, we want to start with the parent function. So the parent function of this is just this part right here. So the parent is log base 4 of x. So we know this is a log, so remember, it's going to go through 1, 0. Here's our base, so base 1. And the asymptote is going to be at x equals 0. So we're going to graph those three things. Our asymptote, remember, if it's an exponential function, the asymptote goes left to right. If it's a logarithmic function, it's going to go up and down. So the 2 points we're going to go through are 1, 0 and 4, 1. And so we're not even going to graph this right now. But what we're going to look at is how this parent function is going to change because of these transformations here. Okay, so remember this one inside the parentheses is left and right, and it's changing signs. So this is going left 1, and outside the parentheses is up and down, and we keep the sign. So this is going, whoops, not up, down 2. So we're going to take everything here, the asymptote and these 2 points, and we're going to shift them left 1 and down 2. So we're going left 1. There's our new asymptote, because the vertical shift isn't going to change anything on the asymptote. So now we're going to take each point and go left 1, down 2. Left 1, down 2. And so our new graph is going to look very similar to this. And again, we can take out this old asymptote. I suppose maybe I should keep in the new stuff, huh? Okay, domain and range, again, remember, are going to be switched from an exponential function. So start with our asymptote. Our asymptote in this case is x equals negative 1 because we moved it to the left 1. Our domain is going to go from the asymptote to positive infinity. And our range is going to go from negative infinity to positive infinity. All right, so we want to look at the red graph, okay? We know that's our parent function, right? And we know that it's the parent function because the asymptote is at x equals 0, okay? So the base for that parent graph, we know that they're all going to go through 1, 0, and base 1. And x equals 0 is going to be our asymptote. So we have to figure out, we've got to look for the point that has a number and then a 1 in the y place. So that's this one here, which means that our base is going to be equal to 2 for this one. And since our asymptote is vertical, we know that this is going to be a logarithmic function. So the parent is going to be log base 2 of x. Okay, now, we have to figure out the equation for the blue graph, which is the transformed function. So the first thing we want to do is we want to figure out where that asymptote is. Okay, so remember, where that line starts to go straight up and down is where our asymptote is going to be. So in this case, it looks like that asymptote has been shifted 3 to the right. So it should be x equals 3. So we went right, 3. Okay, so remember, we're just going to pick a point, any point, okay, and we're going to shift that point right 3, okay, and we're going to hopefully land on the blue line. 1, 2, 3. Well, we didn't land on the blue line, so we need to figure out how many we need to go down before we get to the blue line, and that is 2 boxes. So we went right 3, and we went down 2. So our transformed function is going to start with this exact same parent function. F of x is equal to log base 2 of x. But we have these transformations. Remember, we go right 3, okay? So that right 3 is going to go with the x because x is left and right. But since it's inside the parentheses, we're going to change the sign. So instead of going plus 3, we're going to do minus 3. And this up and down is going to go outside the parentheses, and it's going to stay the same sign. So minus 2. So this is the equation of the blue graph. So again, practice problems. There's also an extra one in there, just practicing graphing, writing equations for both the exponential and the logarithmic functions. So all of those practice problems would be really good ones to look at before you come back. Have any questions, let me know.